Hello all, in this lesson we are going to learn about transformations. I'm going to introduce the transformations that we are going to look at: translation, dilation and reflections, and then also combination of transformations. Let's see how we proceed. As usual, we will start off with our graph y equal x squared. Here it is given in a red line. Red curve is the y equal x squared. Let's have a look at that one. So let me write. Obviously, you can see the blue graph is obtained by a transformation onto the red one. In this case, the transformation is simply moving around. You can obviously see the turning point here, 0, 0, now has moved right as well as up. So in this case, we call it more mathematically, it has moved 2 units in the positive direction of the x-axis. That's the right hand side of the x-axis on the number line, positive direction. And then also 3 units in the positive direction of the y-axis. So you need to get used to that calling. Translating 2 units in the positive direction of the x-axis and 3 units in the positive direction of the y-axis likewise. Now, the 2 things that we are going to look at is, obviously, first one we already know, it has translated. Now what we are going to look at is how to obtain the function for this blue graph. So we need to get the functional form. Obviously, there is no dilation. That means the graph hasn't either narrowed or made it wider. Therefore, we can simply say this graph is of the form x plus h squared plus k form. That means it has only a translation. This also can be written as x minus h in this case rather than x plus h. To be more consistent with what you've seen before. But nevertheless, let's say we do not know yet. Okay, now how do we obtain this graph, or rather the function? Let's assume any given point here is x dash comma y dash. That's my image from a point, let's say a point on this graph which is x comma y. What do I know? I know how y and x are related. How they are related? Y equals x squared. But I do not know how x dash and y dash are related. If I knew that, that would be my functional form for this blue graph. Well, I know how I obtained y dash and x dash based on x and a y. Well, there's a translation, 2 and a 3. If I write down that, I could write down x dash as well as y dash. X dash is basically the x has been moved, or rather translated, 2 units in the positive direction of the x-axis. How about the y dash? Well, you're right, your thinking is good. Y plus 3 in this case, because it's in the positive direction of the y-axis. What I need to do here, the technique step is basically make x and y are the subject in each of these equations, are the subject. And then once I know those, I can simply replace my x's and y here in terms of x dash and y dash to obtain my equation. That's what I'm doing. Okay, let me do that here. If I had that, I would have written x is equal to, in my case I get x dash minus 2. I'm still using my color coding here to make sure that you understand here, or you follow. Y is equal to y dash minus 3. Well, I found x and a y in terms of x dash and y dash. Now what I need to do, I know y equals x squared. Now how do I replace these with x dash and y dash? Well, what is y? Y is basically y dash minus 3. And then I have x. What is my x? Well, I do have the square part here. What is my x? X is x dash minus 2. Now we got the answer. Now let me rearrange this. Now I have y dash, a different color, or maybe a thin writing, x dash minus 2 squared plus 3. When you move the minus 3 into the other side, or the number 3 here. That's my equation for the blue one. Well, obviously x dash and y dash is another coordinates. They are for another set. Therefore, we can simply replace, this is exactly same as if I written y equals x minus 2 squared plus 3. So we obtained the equation of the image, which is the blue graph, the equation for the blue graph based on the red one under the translation of that. So that's basically translating 2 units in the positive direction of the x-axis and positive direction of the y-axis. Okay, and then you can see this is in the general form as we seen before. When you translate, your general form becomes y equals x minus h squared plus k form, where h and k are positive in this case. H comma k are positive. Right, let's move on to the dilation. We again start with y equal x squared. Let's say we would like to dilate away from the x-axis. Okay, away from the x-axis. What does that mean to us? I'll write down the equation here once we've done the working, and then we'll write down how about if I had a graph like fx, how would I write down the dilation factors into this one to obtain our new one. Okay, let's say in this case I'm going to go away from the x-axis. That means my heights are getting higher or lower depending on what number I would like to use. Let's assume I'm going to use number 2. So my heights are twice as high than the red one for the new one. Now in this case the height is actually 2 comma 4. On my graph I don't have the next height, which will be 2 comma what? 4 times 2 is 8, isn't it? So it's 2 comma 8. You can write down there, and then you can obtain the graph. Obviously 0 comma 0, multiplying that by 2 doesn't make any difference. Hence the graph looks like this. So it should come down nicely. Well, it's a little off, but that's fine, just for understanding. Right, okay, let me make it a bit better. That's better. There you go. Likewise, now what has happened, my new point or new coordinates x dash y dash, and it started off with xy, which is x comma y. My new coordinates x dash y dash is x dash doesn't change, it is same as x, but the y dash has become twice the height. Now when I make y the subject, you get y dash on 2. Now what I can do is simply replace my original equation y equal x squared with y dash and x dash. What do I get? Y dash on 2 is equal to x dash squared. That gives me y dash equals 2x dash squared. Now you can see what happens with the dilation factor is the factor goes underneath as a denominator for the respective axis. Now I'm going to replace x dash and y dash with x and a y. That gives me y equals 2x squared. You have to be careful, this number 2 is outside, so it's multiplying every height for x squared by 2. That's what it means. Now in terms of our original equation y equals fx, how does that work with a dilation from the x-axis? Well, let's say the factor k, so if the factor was k, then y becomes y on k equals fx. That will give us the functional form y equals k times fx. This is quite intuitive, isn't it? So you multiply every height by k. But what happens if the dilation is away from y? So let's say the dilation is away from y, means my x dash or the image becomes twice as, or maybe let's say another factor. I'm going to use d here, d times x. That means in our case, if I assume d is 2, that means you are going twice as far away from the y-axis you were before to get the new one. In this case, x becomes x dash on d. So you're simply replacing x with x dash on d, which means our functional form becomes y equals f, x becomes x on d. So you can clearly see the dilation factor goes as the denominator. What it means is, if I had two dilations, which means away from x and away from y, k and d respectively, then my new equation becomes k f x on d form. So that's my final version, including dilations both from x and y axis respectively. Okay, that's how you obtain the equation, simply finding the image, making the x and y subject, and then replacing x and y in your functional form in fx. That fx could be any functional form with this, under these transformations. So that's in general. Let's have a look at the reflection. Now you can clearly see this is getting quicker. With the reflection, what we are going to do is we are going to either reflect through the x-axis or y-axis. What happens if I reflect through the x-axis? What do we get? If I reflect through the x-axis, the image, let's say here xy, the image of xy becomes, just further down here, it's through the x-axis now. Just in there, x comma negative y, or rather let's write down as same as before. So what we get is x dash is same as x, but y dash is simply the value which is negative, therefore you get negative y. Hence if I made y the subject, I get negative y dash. And then if I replace my functional form, in this case obviously y equal x squared, now I have negative y dash equals x dash squared. Hence I get y, or rather negative y, I replace x dash y dash again with x and y, gives you that, yielding final answer as negative x squared. So the negative is in the front, not this, not that one. X squared and then the negative, which means you consider the negative, you are reflecting through the x-axis. Now what happens if it is in the form of y equals fx then? Well, obviously your fx is now x squared. Your image becomes, or rather under this transformation, y equals negative fx. Now that's our final equation for, in general, graph fx. How about if I reflect through the y-axis? Well, it's the same manner. I can reflect through the y-axis. In this case it is symmetric, therefore it doesn't make a difference for our function. But if it was fx, let's consider x dash now is in fact negative value of x, because you're going either to the left side or the right hand side depending on where you start. That gives us x is negative x dash, and y dash, the height stays the same, it doesn't change, stays the same. Now if I replace y equal fx with y dash and x dash, what I get is y dash equals f of negative x dash. Now you can clearly see this can be written as f negative x. Let me do that again. And is our final form of the image, or the equation of the image under the reflection through the y-axis. Now we got a better understanding of how to find the image equation, or the equation of the image of any given graph under any transformation. What we can now do is we can go ahead and work on combination of transformations. We'll stop here for now, and then we'll catch up again in another video lesson to go through the combinations of transformations. Until then, work through the work plan, and happy learning. Thanks all. Bye.